Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR net and the GATE physics exam. So I hope that the discussion which we will be doing today in this session will be getting clear to you. But in case if there is anybody who's gonna have any doubt and is not gonna understand something, we will be talking about that point as well, guys. So I'm just quickly going to tell you something related to the latest offer and some other important things, and then we are ready to start our discussion. So actually guys, if I'm going to talk about the latest offer which is going on Unacademy, as per which you will be able to save more and you will be able to get the great discount in the total subscription amount. So you can have a look at this slide. This is going to help you to get the great discount in your total Unacademy subscription amount. Also guys, you can use and apply the code that's Anjali Alive to get the discount in the total subscription amount. The another thing is, even if any of your friends want to take the subscription, you can share this information with them to let them know about it, and along with the referral code, because to get the discount anybody needs to use and apply the code that's Anjali Alive. Now let me just quickly show you what are the benefits you will get if you are going to take the Unacademy Plus Iconic or the Lite subscription. So actually guys, as you can see in the respective subscriptions, you're going to get the different benefits, and depending on whichever you find more beneficial for yourself, you can take that particular subscription. Even in the Plus and the Iconic subscription, guys, you will be able to get the like access to the important notes which are now available on the Unacademy Learning app, which will even be helping you to take your preparation to a very good level. So in the Plus and Iconic subscription, you are going to have more benefits you're going to get, and as per what you think will be helping you more and will be more helpful to do the best preparation, you can take that subscription. Okay, now let's go ahead. Let me just show you a few more slides and we are ready to start our discussion about the important questions. This slide is regarding the Unacademy Learning app. This is something about the session. Here are a few details about me, and this is related to community feature we are having on Unacademy Learning app, which will be helping you to stay updated, to know about the latest updates and the information. So this is how guys everything will be helping you a lot and will be helping you to know more about the important things, right? Okay, let's go ahead with the discussion now. Clear? So I'm going to talk about thermodynamics and statistical physics today. We will be trying to consider the questions from both the sections, guys, so that you will get to know what type of questions you can expect in your upcoming net and gate exams and even in other similar exams. So that's how this discussion today, what we are going to do, will be helping you. I'll write the first question now. Also guys, anywhere if you will be having any doubt, you can surely let me know about it, so that we will be going through that part. So for that, you just need to comment and I'll be checking your comments too. From which section you want me to take your first question? From any one of thermodynamics and statistical, or just a particular section? You can mention it in the comments. And your first question which I'm gonna consider is here. the system has an energy less than 4 h cut omega 1. In the following x is equal to e to the power negative beta h cut omega 1, and z is the partition function of the system. Options are try it now, guys, and if you will have difficulty in solving it, so I'm going to help you in that case, that what steps you have to take and how you will be able to proceed further to solve it. So that's what we will talk about, but I want you to even have a look at the given details in the question and what they have talked about. What do you think you will be doing to solve it, so all that even you can consider, and let me know what do you think will be the right answer according to you. And if you're not gonna get it, don't worry, then I'm gonna help you. So first of all, you have to understand the given system. They are talking about the frequencies like omega 1 and omega 2. So in that situation, what will happen? If you will consider in what kind of systems you're going to have the frequencies. So that's going to be harmonic oscillator, right? So what is the energy expression of the harmonic oscillator? It's going to be, since we are having two different frequencies given to us, we can consider it to be n1 plus half h cut omega 1 plus n2 plus half h cut omega 2, right? Now you have to consider the values of n1 and n2 here, like 0, 0, 0, 1, 1, 0, 1, 1, whatever possibilities are there. Depending on that, you will be getting the energies, right? Now you have to consider all those possible values of n1 and n2, and also omega 2 you can replace with 2 omega 1, which will be giving you energy less than 4 h cut omega 1, right? So in that case, what will happen when you will plug in 0, 0? You will get half plus half and 2 omega 1 at place of omega 2. So 2 plus 1, 3 h cut omega 1 divided by 2. It's less than 4, yes. So that you can consider, right? Other than that, if you will plug in the 1, 0 or 0, 1, what energies you are going to get? Let's check them. So for 0, 0, n1, n2 values, I am getting 3 by 2 h cut omega 1. For 1, 0, I will be getting, this will remain 2 by 2 because omega 2 will get replaced with 2 omega 1. Okay, 2 by 2, and this will be 3 by 2 now. So that is 5 by 2, which is 4 less than 4 h cut omega 1, right? Okay, now next we are going to consider the 0, 1. So when we are taking 0, 1, it will be 3 by 2. It will be basically 6 by 2, not 3 by 2. Why? Because 2 omega 1 will be outside, right? So 6 by 2, and then here you are going to have half, that is 7 by 2, which is again less than 4 h cut omega 1, because 7 by 2 will be 3.5. So for 0 1 you're gonna have 7 by 2 h squared omega 1, right? If I'm going to talk about the next one, that's going to be 1 1, which is 3 by 2, or you can say 6 by 2 because of the 2 outside the bracket, this part. Okay, so 6 by 2, and this one 3 by 2, 6 3 9, 9 by 2, which is greater than 4h squared omega 1. So you have to see, is there any other combination of n1 n2 you can have, and after replacing omega 2 as 2 omega 1, are you getting the energy less than 4h squared omega 1 with that combination? If it is possible, then you will consider that. Otherwise, you are just going to have these three choices which are going to show you the energy is less than 4h squared omega 1. When you will write the expression for the probability at temperature T, the system has an energy less than 4h squared omega 1. So in that situation, what's going to happen? All the energies which are giving you the value less than 4h squared omega 1, you will write them in the numerator because that's the favorable part. And overall partition function we write in the denominator. Now next thing, summation over n, okay, en, pn, you know that. Or there is going to be the expression in case of, that is for expectation value we use, but here we need to find the probability. So in case of statistical physics, what is going to happen? Summation over I, gi, e to the power minus beta ei. Ei is the energy here, beta is 1 over kbt. So you have to take all the favorable values sum in the numerator. So degeneracy for different cases you have to check out, like if you're gonna plug in 2 0, is there any value which is getting repeat? So let's even check for 2 0, what will happen? For 2 0 guys, we will have 2 by 2 from here, 5 by 2 from here, 5 and 2, that's 7 by 2. So for 2 0 also we are getting 7 by 2. Okay, and if you will see 1 1, is there any possibility with that? I think we have checked it, but you can still check it out with the 1 1. Is there any repeated value you are gonna get? If yes, then it's degeneracy you will get to know. So right now for 7 by 2 h squared omega 1, I'm having the degeneracy 2 because there are two different combinations which are giving me the same energy, right? So let's write the expression. Degeneracy for 3 by 2 h squared omega 1 is what? 1. So e to the power negative beta E is the energy 3 by 2 h squared omega 1. Then plus e to the power negative beta 5 by 2 h squared omega 1 plus 2 times, because that is degeneracy, e to the power negative 7 by 2 h squared omega 1, and beta should also be there. So that's what you are going to get, right? If in case there is anybody having any doubt, just mention it. So what formula we are using? In the numerator, summation over I, gi, e to the power minus beta ei. Gi is basically the degeneracy, which is going to be 2 only for 7 by 2 h squared omega 1. And for all other 2 energy values you got, like 3 by 2 and 5 by 2 h squared omega 1, you got the degeneracy to be 1. So that's how you are going to consider it. Tell me if in case there is anybody having any doubt, we can talk about it then. But if it is clear, that's great. Now, you can see they have given you the e to the power negative beta h squared omega 1 is taken as x. So what you will try to do, you will try to make their form. You can see in the options, x to the power 3 by 2, x to the power 3 by 2, x to the power 3 by 2 is taken common. Means e to the power negative 3 by 2 beta h squared omega 1 you have to take common. Then you will have inside the bracket 1 plus this is e to the power negative beta h squared omega 1 only, because if I will simplify these powers, I'm getting 5 by 2 there. 2 e to the power negative 2 beta h squared omega 1, because 2 to the 4, 4, 5, 6, 7. If I will add it with this power, the initial common power term, okay, and omega 1. That's what we will have divided by z. So it's going to be 1 plus x plus 2x square, right? 1 plus x plus 2x square. So that's going to be option D, which is the correct one. That's how you can consider it. Now let me know if in case there is anybody having any doubt, we can consider it, guys. But step by step, what are the things you need to keep in mind, how you will proceed further, what you need to know, all that we have talked about. I'm going to give you the next question if there is no doubt in this one. But if you have doubt, let me know. I'll talk about it. Done. Okay, let's have a look at the next one then. A given quantity of gas is taken from the state A to C reversibly by two paths A to C directly and A to B to C as shown in the figure. During the process A to C, the work done by the gas is 100 joules and the heat absorbed by 150 joule if during the process A to B to C, the work done by the gas is 30 joules, the heat absorbed is options are 20 joule, 80 joule. Next you're gonna have is 220 joules. Next you're gonna have is 280 joules. Okay, try it now guys and let me know if in case you will have any doubt anywhere. I'm gonna show you that how the process have been shown. So actually we are gonna have A to B, B to C like this, and A to C like this. A, B and C. This is B and B. And the process is taking place in this direction or directly from this to this. Now try it and let me know what do you think will be the right answer. I'll be waiting for your reply. If in case something is not clear, you can surely let me know about it. But if everything is clear, then that's great. Waiting for your reply, guys. And just in some time, I'll be starting the discussion too. Okay, in this case, basically they have given you the information about two different, you can say, two different paths, like, okay, A to C and A to B to C. In that situation, you need to know what is that parameter which is path independent, doesn't depend on path, and accordingly you can find that parameter because it will be same for both the paths followed, and that can help you to find the answer. So let's see what information is given and what else we can relate here along with the given information to find what they have asked us to find. A given quantity of gas is taken from the state A to C reversibly by two paths, A to C directly and A to B to C, as shown in the figure. During the process A to C, the work done by the gas is 100 joules. Okay, the work done is given and the heat absorbed is given as 150 joules. So what will be the internal energy in this case? That will be the heat absorbed and the work done. Subtract the work done from that. So in that case, you are going to have the equation du is equal to dq minus dw. So that's going to be 150 minus 100, which is going to be 50 joules, right? So you are going to get internal energy to be 50 joules. It will be same for the A to C directly path or A to B to C. Okay, for both the paths, this value will remain same. Now you have the internal energy as the 50 joules for both the paths, which means if I want to know about, now I also have the work done for the A to B to C process. So work done is there, internal energy we know, heat absorbed we need to find. So 50 plus 30 joules because you will take the dW on the other side. So that's going to give you 80 joules as your final answer for option. That's option B, which is the correct one, right? Hence, this is the process like you can follow, and that's how you can just work on this type of questions. It's going to be quite easy if we are going to move a step by step, and we are going to check out like what can be done, what can be considered. Now let's go for the next question. A vessel has two compartments. Of volume V1 and V2. Containing an ideal gas at pressures P1 and P2 and temperatures T1 and T2 respectively, if the wall separating the compartments is removed, the resulting equilibrium temperature will be. Options are P1 T1 plus P2 T2 divided by P1 plus P2. Second option is V1 T1 plus V2 T2 divided by V1 plus V2. Option C is P1 V1 plus P2 V2 divided by P1 V1 divided by T1 plus P2 V2 divided by T2. And option D is T1 T2 to the power 1 by 2. Try it now, guys, and let me know what do you think is going to be the right answer. If you're not gonna get it, I'll help you in that case. But if you think you can get the answer, just try. Try. So actually, guys, in this case, it's going to be a vessel has two compartments of volume V1 and V2 containing an ideal gas at pressures P1 and P2 and temperatures T1 and T2 respectively. If the wall separating the compartments is removed, the resulting equilibrium temperature will be what? So you may have heard about the calorimetry principle, guys, as per which we are going to have the equilibrium temperature expression, which is, even they have asked you to find the resulting equilibrium temperature, right? So equilibrium temperature is P1 T1 plus P2. Like, actually we write it this way. Like, you are going to consider the expression which is for the N1 C1 T1 plus N2 C2 T2 for the equilibrium temperature. If you will write it in terms of the specific heat capacity, so after writing the equilibrium temperature as per the calorimetry principle, guys, what we have to do next, we have to consider the ideal gas equation, which is PV is equal to nRT. Why? Because you can see your options have been given in terms of PVT, okay, or just PV, and like all these thermodynamic potentials are present there, which means you have to write your answer in terms of all these parameters. So when you will consider it that way, you are going to find like, okay, I am going to have the PV is equal to nRT equation as per the ideal gas, and that's something which can help you, right? That's what you have to do. Let's write the equilibrium temperature as per calorimetry principle. Write it first, guys. Okay, and then replace PV is equal to nRT. Okay, in this case, what happens when you talk about the same substance, you know that each molecule mass will be same if we are having a compartment, like two different compartments given to us, and you know both sides there is ideal gas, so you will say each particle's mass is same. So in that case, if there are n1 number of particles, m1 can be replaced with n1m and c1t1 plus n2m and c2t2, right, divided by m1c1 plus m2c2. This is what you will have. So m1 again in the denominator you will be replacing with what? With the n1m, n2m. The reason behind that is because you know that the same substance is there at both sides. So in that case, each particle's mass is same, and that's how you're gonna get it. Now you will take m common, m common, m common from each term and cancel it out. So your equation becomes n1c1t1 plus n2c2t2 divided by n1c1 plus n2c2. Now even if somebody will say equal number of particles are there on both sides, then you can even replace n1 n2 with the n and you can simplify it. Or since you know same substance is there, so specific heat capacity will be same as well, which means c1 and c2 are same, so they will even get simplified. So your final equation will be n1t1 plus n2t2 divided by n1 plus n2. Now as per the ideal gas equation, you know that the PV is equal to nRT. So your NT will be equal to PV divided by R, right? So in this case, you will have P1 V1 divided by R. R is the gas constant, plus P2 V2 divided by R. And if you will talk about what should be in the denominator, so that will be P1 V1 divided by N1R. N1 is already there, so you will say TR because you are going to plug in the value of N1. Okay, plus P2 V2 divided by T1 here and T2 here, R. Now R is a constant, it will get simplified, rest of the terms will remain as it is. So your equation will be P1 V1 plus P2 V2 divided by P1 V1 divided by T1 plus P2 V2 divided by T2. That's it. This is going to be same as given in option C. Let's check. Yep. And that's your right answer then. So that's how you can find it, guys, that what will be your right answer and how you can solve it, how you can find your right answer. Okay, so sometimes we need to plug in the values of some parameters with the help of other equations in the main equation we are working on, and that helps us to get the final answer. So we need to take care of those things while working on such type of questions. Let me just give you the next one, guys. Let's take this one. Give me a second, guys. Try it now, guys. If in case you will have any doubt, we'll be talking about it. Yeah, that's great. Try. Try, try, try. A Carnot cycle operates as a heat engine between two bodies of equal heat capacity until their temperatures become equal. If the initial temperatures of the bodies are T1 and T2 respectively, and T1 is greater than T2, then you have to find their common final temperature, right? So first thing we need to know, Carnot cycle is reversible in nature or irreversible in nature. Depending on that, the change in entropy condition we can apply. So if you will consider for heat Carnot engine, the change in entropy will be what? That's going to be ds, like overall we will see for both source and sink, like that you will write it. So you will write ds1 value, okay, for the source, and ds2 value for the sink. Now their final temperatures we will take equal, so T1 to Tf, and that's going to be dt over T, okay, and T2 to Tf, that's going to be dt over T again. So if you are going to consider this one, it's going to be log, like you will get log T, apply the limits, upper limit and the lower limit. You are going to consider log Tf divided by T1, and from this one you will have log Tf divided by T2, right? So in this case you got the ds1, the change in entropy for source, and ds2, the change in entropy for sink. So total change in entropy will be what? That's going to be ds1 plus ds2, that is the log Tf over T1 plus log Tf over T2, which will be simply log Tf over T1 T2, and Tf square in the numerator. The reason is because you are just gonna write log m plus log n, which is log m times n. That's how you are gonna get it. This should be equal to what? 0, because total change in entropy for the reversible cycle will be 0. Now from here, you are going to take e to the power 0 that side, which will be 1 after removing log from this side. And this will give you Tf is equal to square root T1 T2. That's how you can find it, okay? Tf is equal to square root T1 T2. And that's how you're just going to get your final answer. Let me know if in case there is any doubt anybody is going to have. Otherwise, guys, your option C is the correct option. It's here, okay? So that's how you can do it, guys. If in case still there is anybody having any doubt, you can let me know about it. But if it's clear, that's great. So let's take the next question now. And next question we are going to have is the one I'm going to write right now. Give me a second, let me just make some space here, and then we are going to go ahead with the discussion. Okay. Next one is this. The free energy F of a system depends on a thermodynamic variable psi as F is equal to negative A psi square plus B psi to the power 6 with A comma B greater than 0. The value of psi when the system is in thermodynamic equilibrium is. Options are 0 plus minus A divided by 6b to the power 1 by 4. Option C is plus minus A divided by 3b to the power 1 by 4. Option D is plus minus A by B to the power 1 by 4. So try it now and let me know what do you think will be the right answer according to you and how you are gonna go ahead to solve it, guys. Just go through it once and tell me if in case you will be having any doubt anywhere. We will talk about it then. So the free energy F of a system depends on a thermodynamic variable psi as F is equal to negative A psi square plus B psi to the power 6 with A comma B greater than 0. The value of psi when the system is in thermodynamic equilibrium is what? So actually when we are talking about the function given to us, okay, we want to find at the equilibrium what will be the value of psi. So we just have to do simple thing. What you do to find when the function is in equilibrium, what is the value of the variable? Like the variable is psi here, so we have to find the value of psi. So we just simply differentiate the expression with respect to that variable, like delta F over delta psi, and then we equate it with 0. So it will give us negative 2a psi plus 6b psi to the power 5, that is equal to 0. So from here, if you will take one sign common and you will just remove it, 2 times the sign you can take it common, okay? So you will get negative a plus 3b psi to the power 4 is equal to 0. It will give you a divided by 3b to the power 1 by 4. That's option C, which is same like the expression we are getting. Hence our option C is the correct option. You can tell me if in case there is anybody having any doubt, we can talk about it, guys. But if it is clear, that's great. We will go over the next question. And if there is any doubt even now anybody is gonna have, you can let me know. We will talk about that point. But if everything is clear, then that's great. So let's take our next question as the one I'm gonna give you now. That is interesting because it's gonna help you to know about the other important formulae and other important things too. So your next question is the partition function of a system of n Ising spins is z is equal to lambda 1 to the power n plus lambda 2 to the power n, where lambda 1 and lambda 2 are functions of temperature but are independent of n. If lambda 1 is greater than lambda 2, the free energy per spin in the limit, the free energy per spin in the limit that's going to be n tends to infinity is. Options are negative kBt log lambda 1 divided by lambda 2. Second option is negative kBt log lambda 2. Now option C is negative kBt log lambda 1 times lambda 2. Option D is negative kBt log lambda 1. Try it now and let me know as you will get it done, guys. And if you're the one who doesn't know about the process or the steps you need to follow to get its answer, it's okay, I'll help you in that case. But if you think you know it and you know what to do and what are the steps you need to take, go ahead with that. Otherwise, like, you can tell me if in case you are having anything not clear, some hint you want to get, we can talk about it. So the partition function of a system of n Ising spins is z is equal to this, where lambda 1 and lambda 2 are functions of temperature but are independent of n. If lambda 1 is greater than lambda 2, the free energy per spin. So do you know what is the free energy formula related to partition function? That is negative kBt log z, right? So if we will consider negative kBt log z, depending on what z expression is given to us, here lambda 1 is greater than lambda 2. So if you will divide lambda 2 by lambda 1, it will give you a smaller value, right? Because lambda 1 is greater and lambda 2 is smaller. So you are dividing the smaller value with larger value. So it will give you more smaller value that way. Once you will have this, but how you can form this kind of vector? So you know negative kBt log z is your free energy formula. So you will have negative kBt log z is what? That's lambda 1 to the power n plus lambda 2 to the power n. So lambda 1 to the power n, when you will take, it's going to be 1 plus lambda 2 over lambda 1 to the power n, and that's what you are going to have, right? In this case, this is going to be too small. So when you will add it in 1, you can say we are getting approximate 1 value. So it will give us negative n kBt log lambda 1. Along with that, guys, if you want to find the free energy per spin means you are just going to divide by n, which will give you kBt log lambda 1. So your final answer is option D. So you can see that when you will divide it by n, you are going to have same as given in option D, negative kBt log lambda 1. Tell me, guys, if you're going to have any question, query or doubt regarding this, we can talk about it. But if it is clear, we are going to take our next question then. So as per our next question, I hope you are going to find it interesting, because even there are times when most of the students were making mistake in such type of questions, okay? And even right now at present, there are students, those who solve it for the first time, they make mistake in such type of questions. So if you don't know about it and you are even the one who has not worked on such type of questions till now, and there is a chance of making mistake, I'll explain it to you that how to do such type of questions then, okay? Have a look at this. Consider a random walk on an infinite two-dimensional triangular, okay, lattice, a part of which is shown in the figure below. Is shown in the figure below. And then the figure which is given to you looks like this. I'm just gonna draw it here. Just gonna draw it here, one more line, then one more line, that's it. So it's gonna be something like this, guys. This way, then this way, then this way, and then this way. Okay, like they will be equal, but if they are not looking like equal, you can consider they are equal. This way, then we will have something like this, something like this, something like this, something like this, right? That's what we are going to have. Now again, I can extend it to this point, this point, this point, and this point. So this is the type of lattice we are going to have actually, guys. Now next question statement. In this case, if the probabilities of moving to any of the, if the probabilities of moving to any of the nearest neighbor sites are equal, what is the probability that the walker returns to the starting position at the end of exactly 3 steps. End of exactly 3 steps. Options are 1 divided by 36, 1 divided by 216, 1 divided by 18, 1 divided by 12. Try it now, guys, and let me know what do you think is the right answer. If you are not gonna get it, we will be talking about it then. So there is a random walk on an infinite 2-dimensional triangular lattice, a part of which is shown below in the figure. And then if the probabilities of moving to any of the nearest neighbor sites are equal, what is the probability that the walker returns to the starting position at the end of exactly 3 steps? So this lattice is not just the one you can see here, it's extended all sides, you will have more part of it, but a limited portion has been shown. Okay, now we have to consider an initial position of the walker. Let's say it's here. So here we are gonna have the walker at present. So it has to take 3 steps, and at the end of 3 steps the walker should come back to the actual position or the initial position. So in that case, in how many different ways it can take its first step? So if you will see, it can go this side, this side, this side, this side, this side, this side. It is not restricted to stay or to go only in one particular or few particular sides. Okay, it can take the first step anywhere. So how many are the favorable steps? 6 out of total 6. So 1, 2, 3, 4, 5, 6. 6 out of 6. Then if I'm gonna say the walker moves this side, this is the first step of the walker. So when this is the first step of the walker, after that if he has to take the second step, in how many ways he can take the second step in such a way that after exactly 3 steps he should come back to its actual position. So either he has to go this side or he can go this side, because only then he can come back to the actual position after just one more step or the third step. So you can see that 2 are in our favor, so 2 out of like 6. Okay, then if we are gonna reach here, then how many are in our favor? Just 1. Or let's say earlier in the previous step we moved this side, then again just 1. So any one side you will move, okay, in your second step. So 1 out of 6 in the next step is in your favor. Now it's going to be 2 divided by, or you can just simplify it here, 2 by 1 by 3, that is 1 by 18, which is option C, and that's your correct answer. Tell me guys, if in case you're still having any doubt, we can talk about it, but if it makes sense and you're getting it, that's great. That means we can take the next question. Okay, let's take the next one, and you can even tell me if anywhere you will have doubt. In a thermodynamic system in equilibrium, in a thermodynamic system, in equilibrium, each molecule can exist in 3 possible states with probabilities 1 by 2, 1 by 3, and 1 by 6 respectively. The entropy per molecule is, the entropy per molecule is, options are Kb log 3, then next one is half Kb log 2 plus 2 by 3 Kb log 3, 2 by 3 Kb log 2 plus 1 by 2 Kb log 3, 1 by 2 Kb log 2 plus 1 by 6 Kb log 3. Try it now and let me know as you will get it done. And if in case still you will have any doubt, we will talk about it then guys. So try and tell me, what do you think is the correct answer according to you? If you don't know the related formula, I'll help you in that case. And if you know it, you can start working on it and tell me what is the right answer. Waiting for your reply, and then just in some time I'm even gonna explain it, what you have to do and how you will be proceeding further to get your answer. Excuse me. So do you know the entropy formula in terms of probability? If yes, that's great. If no, then okay. Now it's going to be your in a thermodynamic system, in equilibrium, each molecule can exist in three possible states. Oh, I have already considered that part, right? So I just need to tell you that what you have to do in this case. So guys, our formula for the entropy in terms of probability is negative kb summation over I pi log pi. That's what we are going to have. So in this case, what will happen? It's going to be negative kb. What are the probabilities we are having? 1 over 2 and 1 over 3 and 1 over 6. So 1 over 2 log 1 over 2 plus 1 over 3 log 1 over 3 plus 1 over 6 log 1 over 6. Right? So that's what we are going to have. Now, as per the properties of log, we are going to have the simplification part to follow. Half log 1 minus log 2 plus 1 over 3 log 1 minus log 3 plus 1 over 6 log 1 minus log 6. Like, so log 6 can be written as log 2 times 3 and then log 2 plus log 3, right? So right now I'm writing just 6 there. Log 1 is what? It's 0, 0 and 0. That's what you can do. And now the next thing is negative kb, and negative you can take common from the inside part as well. So you will have the half log 2 plus 1 by 3 log 3 plus 1 by 6 log 2 plus 1 by 6 log 3. Done? In this case, what will happen? In this case, you are simply going to consider the simplification of log 2 terms together, which will be 4 by 6, which is 2 by 3 log 2, and the other one you will have the 3 by 6, which is 1 over 2, right? So 4 by 6 is 2 by 3. So I'll simply have kb 2 by 3 log 2 plus 3 by 6, which is 1 by 2 log 3. That's what you will have. So kb 2 by 3 log 2 plus 1 by 2 log 3, right? And that's your option C, which is the correct option. So there is no such thing that always the option C will be correct. It's just we are getting that, okay, the type of questions we are going to have. So don't consider that you are always going to have the option C to be the correct one. Let's take the next question now, guys. If in case you are going to have any doubt anywhere, just mention it, let me know about it, and we will talk about that. Here is our next question now, which is the number of microstates of a gas of n particles in a volume V and of internal energy U is given by. Omega as a function of U, V and N. V minus NB to the power N. AU divided by N to the power 3 and divided by 2. Where A and B are positive constants. The next you're gonna have is its pressure P. Oh, we need another slide. We need another slide here. Okay, let's have a look at this. Its pressure P volume V and temperature T are related by P plus AN over V. V minus NB is equal to NKBT. Option B says P minus AN over V square V minus NB is equal to NKBT. Option C is PV is equal to NKBT. And option D is PV minus NB is equal to NKBT. Try it now, guys, and let me know as you are gonna have any doubt or as you're gonna get the final answer. So you can tell me about it. Look at this. This is your question. Okay. If in case you are having any doubt or you want to get some idea or the hint about it, you can just mention that part. Tell me, do you know the main formula you have to use? If you know it, that's great. If you don't know, I'll help you. So, the number of microstates of a gas of n particles in a volume V and of internal energy U is given by this. This is your number of microstates expression. Excuse me. Its pressure P, volume V and temperature T are related by what? Okay, so that's a kind of equation of a state PVT relation you have to find. Now what you can do in this case, that's what you have to see. Think about it, and you can see the questions are mainly from the basic section, but if anybody has done a little bit revision or somebody knows about the basics, it can be quite easy for them to solve it. So as anybody is gonna get the answer, just mention it. What is the correct answer according to you guys? What do you think is the correct answer? I'll wait for you for some time and then we will go ahead for the next discussion. Try. So we know there is a relation between entropy and the number of microstates. What is that? S is equal to Kb log omega, okay, or K log omega. So omega is already given to you. You can write this expression in terms of entropy, like S is equal to K log omega. The omega which is given to you, when you will plug it in here, you are gonna have the expression like, if you will simplify the log part or you will use the logarithmic properties, nk log v minus nb plus 3 by 2 log au divided by n. Check it out and tell me if in case there is anybody having any doubt. So you had the two term, like the product of two terms, which was v minus nb and the au over n. So you know log m multiplied with n gives you log m plus log n. So that's how we just separated it, and the powers have been simplified after that. Now once you have considered this part, guys, we know the expression of the du, that is TDS minus PdV, right? So in this case, what will happen? Once you're gonna have TDS minus PdV, from here if I will ask you to get the expression for 1 over T, that's simply going to be delta S over delta U at constant V. And when you will consider the expression for P by T, okay, because you are just simplifying these two, so P by T will be equal to what? That will be equal to your delta S over delta V at constant U. like that. Okay, so you're gonna get it this way. If you're gonna simplify the first equation, you are just going to get 1 over t is equal to, or from this one you are gonna get, after simplifying, let me just show you, delta s over delta u. You just have to consider this part because you are differentiating with respect to u, and that is the partial differentiation. So then you are gonna get 1 over au over n, and then you are having a by n in the numerator as well. So then you are just gonna get 1 over u, so 3 by 2, 1 over u. Okay, and the another thing is, you will have on the other side the nkb is even along with that, right? Nkb, that's it, 1 over t. So you're gonna get u is equal to 3 by 2 nkbt. This is how you will also simplify your second equation, delta s over delta v. So when you will do that, you are just gonna simplify this part, and what it will give you, just see what you are gonna get from the second equation. That's going to be delta s over delta v. So I'm going to show you here, guys. P by T nkb divided by v minus nb. Then again we'll differentiate it with respect to v, the bracket term, which will be giving us just 1. Okay, and this is how, when you will simplify it, you can get the equation as after cross multiplying and simplifying p v minus nb and nkbt. Now look at the given options. The option D is exactly same as what you have got there. P, V minus NB and NKBT. If you are thinking why not the first equation we got from this first condition, just because it's not present in the options. So what you need is what you got from the second condition. Okay, and that's your right answer. Let's take the next question now, guys. If in case you have any doubt or something is not clear, tell me. I'll consider that part. A closed system having 3 non-degenerate energy levels. Energy levels with energies E is equal to 0 and plus minus epsilon is at temperature T for epsilon is equal to 2 kBT. The probability of finding the system in this state with energy E is equal to 0 is finding the system in the state with energy E is equal to 0 is, okay? Options are 1 over 1 plus 2 cos hyperbolic 2. Option B is 1 over 2 cos hyperbolic 2. Option C is 1 over 2 cos hyperbolic 2. And option D is 1 over cos hyperbolic 2. Try it now and let me know as you will get it done. If in case there will be any doubt anybody will have, we will talk about it, guys. But if it's gonna get clear, that's great. So I'm just gonna wait for your reply, and then we will go ahead with the discussion. So a closed system having three non-degenerate energy levels means their degeneracy is 1. For 0, plus epsilon, and minus epsilon, their degeneracy is what? That's 1. Is at temperature T, for epsilon is equal to 2 kBT, the probability of finding the system in the state with energy E is equal to 0 is what? That's what you have to find. Try it, and if you want to ask something, you can just mention it in the comments. Let me know. So you have to find the probability of finding the system in the state with energy E is equal to 0, right? So it's going to be the favorable energy part, e to the gi e to the power negative beta ei. That's going to be in the numerator, divided by the partition function, which is summation over I gi e to the power minus beta ei. So for plus epsilon, for minus epsilon, for 0, all the terms will be in the denominator. With the 0, we will get 1 because e to the power 0 is equal to 1, plus e to the power negative beta epsilon plus e to the power positive beta epsilon, right? And another thing is you are just going to have this as your value of probability, and epsilon value which is given is 2 kBT. So epsilon is 2 kBT and the beta is 1 over kBT. So what will happen in this case? It's going to give you 1 divided by 1 plus, if I'm writing the positive power term, first of all, it will give me e to the power just 1, okay, plus e to the power negative 1. Oh, it's 2 kBT, right? So 2 and negative 2. But this is not going to match with the options which have been given, because options are in terms of cos hyperbolic. So what I'll do, I can divide by 2 and I can multiply with 2 here. So that's going to be 2 cos hyperbolic 2. So it's going to be 1 divided by 1 plus 2 cos hyperbolic 2. And that's going to be your right answer where it is. It's option A, which will be the correct one. Please tell me if in case there is anybody having any doubt. We will consider it then. But if it is clear, that's great. We are going to take the next question then, guys. Let's take it. If there is anything you want to ask about it, you can just surely mention that part. But if it's clear, I'm going to take the next question then. The maximum intensity of solar radiation is at the wavelength of lambda sun, that is approximate 5,000 angstrom, and corresponds to its surface temperature, that's 10 to the power 4 K. If the wavelength of the maximum intensity of an X-ray, star is 5 angstrom. Its surface temperature is of the order of, its surface temperature is of the order of. Options are 10 to the power 16K, 10 to the power 14K, 10 to the power 10K, or is it 10 to the power 7K? Okay, that's Kelvin. Now try it and let me know what do you think is the right answer according to you. If in case you will have any doubt, we will be talking about it. But if you think you can do it, then try and let me know what do you think is the right answer according to you guys. Try and let me know what do you think is the correct answer. The maximum intensity of solar radiation is at the wavelength of lambda sun, which is going to be approximately 5000 angstroms, and then corresponds to its surface temperature. So firstly they talked about the wavelength, and then they're talking about the temperature. If the wavelength of the maximum intensity of an X-ray is this 5 angstrom, its surface temperature is of the order of what? So actually, as per the Wien's law, we know the product of lambda with the T must be a constant, means lambda 1 T1 must be equal to lambda 2 T2, right? In this case, what will happen if I'm going to talk about lambda 1 and T1 value? So lambda 1 is actually given to us as the 5000 angstrom, and the T1 is 10 to the power 4. Okay, and the lambda 2 is, that's going to be something 5 angstrom, and the T2 you need to find. So it's going to be 10 to the power 4, 5, 6, 7, 7. Okay, that's your answer. That's the value of T2. So 10 to the power 7 Kelvin. Please let me know if in case there is something not getting clear to anyone. We can talk about it then. But if it is getting clear, guys, that's great. We are ready to consider the one more question. Okay, but you can mention it if in case you're gonna have any doubt. Next question is, that's going to give us okay, let's take this one, guys. The entropy S of a system of n spins, which may align either in the upward or in the downward direction. Is given by S is equal to negative KBN P log P plus 1 minus P log 1 minus P. Next we are going to have is, here KB is the Boltzmann constant. This is 1 minus P. The probability of alignment, the probability of alignment in the upward direction is P. Is P. The value of P at which the entropy is maximum is dash. Now options are 0, 1 over 2, 1 or 3 by 2. Try it now and let me know as you will get it done. Try. If in case you will have any doubt, we'll talk about it. So entropy is given to you this time and you need to find the probability of alignment in the upward direction is P. The value of P at which the entropy is maximum. Okay, so you know for maxima or minima what we need to do, we need to differentiate, and that's the function of P. This time the S is the function of P, so we will differentiate the S with respect to P and we are going to equate it with 0. So what will happen in this case, it's going to give us P 1 over P, which will be getting cancelled out. Then again 1 minus P, 1 over 1 minus P will get cancelled out, but you will have just negative 1 remaining there. So negative 1, okay, and same way, 1 P, and then you are, see, it's the product, right? So you're going to use the product rule. So P as it is when you are keeping, so 1 over P will have, which is going to give you 1 there, but then log P as it is, then P differentiation will give you just 1. So you are getting 1 plus log P plus 1 minus P will get cancelled out when you are doing the differentiation of second term, but you will get negative 1 from there, plus log 1 minus P. Okay, this is what you will have, it's equal to 0. This will get cancelled out and this is going to give you, and when you are doing the first one differentiation, you are going to get negative 1 from there as well. So here you will have negative 1. Log P divided by 1 minus P, that is equal to 0. It will give you e to the power 0 as 1. So 1 minus P is equal to P, which is 2P. P is equal to 1 over 2. Hence your right answer will be option B, which is the correct one, which is 1 over 2 itself. So guys, what we will do, we will be keeping it this much right now in this session. If in case you will have any doubt anywhere, you can surely let me know. But if it is clear, we have worked on so many different type of questions today in this session. I'm quickly going to show you the slide regarding the latest offer, which is this one, as per which you will be able to get the discount in the total subscription amount by using and by applying the code Anjali Live as mentioned here on the screen. So guys, you can get the discount in the total subscription amount by using and by applying the code Anjali Live to get the discount in the total subscription amount. Also, this offer is valid till 12th August, guys. If you want to grab this offer, you can take the subscription before that. Along with that, you can share this information with your friends too. And here we are having the details about the Plus, Iconic and the Lite subscription. What are the benefits you will get? Even if anybody is taking Plus or the Iconic subscription, they will be able to check out the important notes as well. So guys, I hope now it's everything is clear to everyone and you can share the information about it with anyone who you think like will require this, will need to start their preparation in upcoming days under the guidance of top educators. Then you can let them know about it. Thank you so much everyone for joining this session and for attending it till the end. Thank you. Bye. Take care. We'll have more sessions.